Welcome to another video of Advanced Higher Maths, and today we will be looking at some practice questions to do with partial fractions. So let's get straight into it, and for a little warm-up, I think we'll only do 2 or 3 problems, quite a straightforward topic, and mainly you'll see a decent amount in the next topic. For integration, you'll need to use it. In fact, quite an interesting point about partial fractions is the fact you never actually get a question for partial fractions on its own. It's always within an integration question, but it's still very useful because nearly always a skill is going to appear in the exam. It'll usually be part A, split blah 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 into partial fractions, part B, hence integrate blah blah blah. You'll see how it's used in integration soon. So let's say question 1 is going to be to split 3 over x plus 1 x minus 2 squared into partial fractions. So have a go. Alright, so we've had a go. So this is equal to a over x plus 1 plus b over x minus 2 plus c over x minus 2 squared. Now this means, through steps, which you can go for if you do wish to inflict yourself the pain, that 3 is equal to x minus 2 squared plus b x plus 1 x minus 2 plus c x plus 1. Alright, so now we're going to plug in a couple of values to solve for various parts. So first of all, we're going to plug in x is equal to -1. So this makes these two terms disappear, and so we're left with, so -3 squared is 9, so 9a is equal to 3. So a is equal to 3 over 9, which is 1/3. Alright, now we're going to plug in x is equal to 2, which is going to make this and this disappear, and we're left with 3c is equal to 3, which means that c is equal to 1. And now we can plug in values back into here, but first expanding brackets so that we're able to compare terms to then see what b is. So 3 is equal to ax squared. This comes from expanding these brackets. I'm just going to do it on one step. So ax squared, so squared is a squared plus 2ab, so that's minus 4x, minus 4ax plus 4a, plus bx squared. In fact, what we could do is, sorry, it's meant to be capital A, is we can compare just for the x squared term. So dot dot dot, that continues. There's no x squared term in this, right? This is just cx plus c. And so the x squared terms are ax squared plus bx squared for this side, but for the other side it's 0, so this must be equal to 0. But we know a is equal to 1 over 3, so this means that x squared over 3 is equal to negative b x squared, so these cancel out. So 1 over 3 is equal to negative b, i.e. b is equal to -1/3. So now we've solved for a, b, and k, as the phonetic pronunciation would say. And so we can plug this back in to our original equation and get it. So a is 1 over 3, so 1 over 3x plus 1. Then b is -1/3, so -1 over 3x minus 2. Then c is 1, so plus 1 over x minus 2 squared. So well done. Solved the first problemo. Now let's look at a maybe slightly more complicated problem, which is going to be to express, I'm going to write it over here because otherwise I have a feeling we're going to run out of space, x cubed plus 9x squared plus 15x minus 39 divided by x squared plus 5x minus 6 into partial fractions. So press pause, have a go. Alright, so remember this is an improper fraction and so we're going to have to divide first to get a lower degree on the numerator. So x cubed plus 9x squared plus 15x minus 39 divided by x squared plus 5x minus 6. Insert time lapse, which I won't insert, but a long algebraic division just takes time, but quite simple. Minus 5x squared plus 6x, that's 4x squared plus 21x minus 39 here, then plus 4 here, so minus 4x squared minus 20x plus 24, that's x, oh, that's meant to be 24, minus 15, so x minus 15, and so we're left with x plus 4 plus x minus 15 divided by x squared plus 5x minus 6. And so now we've reduced the task to just simplifying this into partial fractions. So this in partial fractions, first of all we need to factorize it, so x minus 15 divided by x squared plus 5x minus 6 is equal to x minus 15 divided by x plus 6 x minus 1, which is equal to a over x plus 6 plus b over x minus 1. So this means that x minus 15 is equal to a x minus 1 plus b x plus 6. Let's first of all plug x is equal to negative 6, which gives us that x minus 15 is equal to negative 7a. That's side's meant to be, so negative 6 minus 15 is negative 21. So negative 21 is equal to negative 7a, which means that a is equal to 3. And now we can plug in x is equal to 1 to get that 7b is equal to negative 14, which means that b is equal to negative 2. And so this fraction simplifies to, so a equals 3, so 3 over x plus 6 minus 2 over x minus 1. And so the original thing simplifies to in partial fractions to x plus 4 plus 3 over x plus 6 minus 2 x minus 1, except that's all in brackets. And so it actually remains the same without the brackets, so yeah. There you go, so we've just split that into partial fractions. And now we'll look at one last example to consolidate. Let's say that, let me think, we'll do an example with an irreducible quadratic factor. So we'll say 2 minus x divided by x minus 1 x squared plus 5. So split this into partial fractions, please. I need to be polite. Alright, so I'll assume you've had a go. So it's already factorized for us. So the equivalent expression is a over x minus 1 plus bx plus c divided by x squared plus 5, which means that 2 minus x is equal to a x squared plus 5 plus bx plus c x minus 1. So by substituting x is equal to 1, we can get rid of this, and it gives us, so 2 minus 1 is 1, is equal to, so 6a, which means that a is equal to 1 over 6. And so we now are going to need to do some comparing of terms by expanding the brackets. So 2 minus x is equal to ax squared plus 5a plus, so bx squared minus bx plus cx minus c. So to solve for c, we can compare constant terms. So 5a and c are constant terms here, so 5a minus c, and it's equal to 2. And a is equal to 1 over 6, so 5 over 6 minus 2 is equal to c, by putting this on this side, which means that c is equal to, so 5 over 6 minus 2 is negative 7 over 6. So C is equal to negative 7 over 6. So now we just have B left to solve for. So we're simply going to compare the terms for, well, we can do either for x or for x squared. So we'll go for x squared for no reason except the fact that it's simpler because there's no x squared here. So bx squared plus ax squared is equal to 0, which means that b is equal to negative a, which means that b is equal to, so a is here, so b is equal to negative 1 over 6. So if b is equal to negative 1 over 6, c is equal to negative 7 over 6, and a is equal to 1 over 6, we can just plug these back into our original expression here to get that 2 minus x divided by x minus 1 x squared plus 5 is equal to, so a is 1 over 6, so then x minus 1, plus bx plus c, so the denominator of 6 goes to the bottom, so it's going to be over 6 x squared plus 5, and then our b is negative 1, so in fact we're going to put a negative here, and then this is just 1 plus 7, sorry, 1 is x, so x plus 7. So we have now split quite a few things into partial fractions, and I hope that this makes you ready for our next topic of integration. Now, integration is of course much more than just partial fractions. Partial fractions is roughly a fifth, I suppose you could say, a fifth, a sixth, maybe, of the integration. But it's a very, very interesting topic. Maybe my favorite, along with differentiation, and I hope you will really enjoy it too. See you then.